Dave again here. We've got a question from your Hayes and Harris Math SL textbook, Chapter 6C.1, Question 8, Part A. In this question, we're given a quadratic equation, and we're asked to find several things: the equation of the axis of symmetry, the coordinates of the vertex, and the axes intersects. And we'll use all of that to make a quick sketch of the graph. All right. We'll start with Part 1. We want to find the equation of the axis of symmetry. In general, when we look at a quadratic, there's several different shapes that they can take. An up shape or a down shape, a smiley face or a frowny face. But they both have an axis of symmetry, and that's what we're looking for. The axis of symmetry can be found using the formula x equals negative b on 2a. These are again the same a's and b's and c's from the quadratic formula. So from here, I can say that a is equal to 1, b is equal to negative 2, and c is equal to 5, which tells me that the equation of the axis of symmetry is going to be negative 2 on 2 times 1. Negative 2 is positive 2, divided by 2 is just 1. So that's my axis of symmetry. Now for part 2, the coordinates of the vertex, you'll notice that the vertex always lies on the axis of symmetry. So I know the x-coordinate of the vertex. The x-coordinate of the vertex is 1. So we just have to find y when x is equal to 1. I know that y equals x squared, take 2x plus 5. But we're going to let x be equal to 1. So that's 1 squared, take 2 times 1 plus 5. 1 plus 5 is 6, take 2 is 4. Therefore, the vertex is at the coordinate x, comma, y, 1, comma, 4. All right, part 3, I'm asked to find the axes intersects, if they exist. So to find the y-intercept, all I need to do is let x be equal to 0. Remember, if you're looking for axes intersects, all the axes intersects, all the y-intercepts occur somewhere on this line, and everywhere on this line, the x component is equal to 0. So I get y equals x squared, take 2x plus 5. That means y equals 0 squared, take 2 times 0 plus 5. That's 5. That's my y-intercept. For my x-intercept, I just have to let y be equal to 0. Because all the x-intercepts occur on this line, and everywhere on this line the y component is 0. So I'll say y equals x squared, take 2x plus 5, but y is 0. So 0 equals x squared, take 2x plus 5. And I get a quadratic equation. To solve this quadratic equation, I could try factorization, I could try completing the square. It's not going to work out cleanly though, because there's only two numbers that I can multiply together to give me 5, that's 1 and 5, and they're not going to combine together to give me negative 2. So I think my first port of call here is either going to be polyroots if I have a calculator, or the quadratic formula. That's going to be negative b, so negative 2, plus or minus the square root of b squared minus 4ac all over 2a. Negative 2 is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 5 is 20, all over 2. And here I see my problem, right here. I see that the discriminant is going to be less than 0. I'm going to have the square root of a negative number. Therefore, there are no real roots, no x-intercepts. This is enough to sketch the graph, so I'll move on to part 4. I determined that there was a vertex, or sorry, an axis of symmetry right here at x equals 1. Then I determined that the vertex was here at the coordinate 1, 4. And then finally I determined that the y-intercept was at 5. Right about there. Now this is the vertex. That's going to be either the max or the min. I know it has to be the min. I know that we're not a frowny-faced parabola because there are no x-intercepts. There are no real roots. So it has to be a smiley face, and it has to be the bottom of the smiley face. So the graph has to look like that.